Today we are going to discuss the Aries recovery algorithm. Okay, like in the last class we discussed about the shadow algorithm. So similarly, the Aries recovery algorithm is also used to recover in terms of when crash occurs to the database. Okay, when there is any severe crash occurs to the database. So Aries recovery algorithm basically consists of three main steps. Okay, as you can see here, the first step is called as the analysis step. In the analysis step, actually the algorithm tries to find out which pages were modified while the just before the crash. That means till the crash occurs, which pages were updated, and those pages are called as the dirty pages. Okay, or you can say updated pages or dirty pages. That means those pages which are being modified. Okay, and which were the active transactions which were there during the time of the crash. So first, whenever the crash occurs, the steps that is taken is the analysis step, and this analysis identifies, basically analysis step is to identify those pages which are being modified, which by the transactions at the time of the crash, and which were the transactions which are active at the time of the transaction. Okay, and then in analysis steps we also find out from where to redo the operations, the point in the log file from where we need to redo the operations. That particular point is also identified during the analysis phase. There is another phase which is called the redo phase. Redo phase is basically for the committed transaction. Suppose the transaction is committed, so it is saved in uh, the log file. So from the log file, every operation is found out, and every operation which were done by the committed transaction are redone. So this is the redo. So redo operation is called to redo the modifications that are done till the system crashed. Undo operation is basically for the transactions which were in progress but not yet committed. So for those transactions we need to abort or roll back. Okay. So in that case the undo operation or scan backward of the operations need to be done using the undo operation, so that the every value that will be modified by the active transaction can be reset to its earlier value. Okay, so that is what the undo phase does. So there are three phases: analysis step, redo phase, and undo phase. Now comes what are the information that are required for the Aries algorithm to basically and accomplish uh, the recovery task. Okay, to recover the data from the whatever the original was till the time of crash. That is, what are the informations? Because there are certain information that the algorithm will require. So these informations are obviously the basic, most important information is the system log, and we all know that system log basically keeps tracks of every operation of the transactions. Okay, and um, uh, transactions and actually it means the affected values by the of the database items by those transactions, right? So those informations regarding the change of the values or affected values are stored in the log file, system log file. Then comes another is the log sequence number, which is called as the LSN. Okay, so every log record actually in Aries algorithm contains an LSN value, which is called as the log sequence number, which is nothing but a monotonically increasing number. Okay, uh, and actually it indicates the address of the log record on disk. Okay, so it is basically a monotonically increasing value. Okay. So it is you can say this LSN number is basically uh, uh, to identify actually to records, okay, in the log file. So it is, so every database will also actually store the LSN, the log sequence number of the latest log record corresponding to any changes that has been done to the pages. So the it is basically stored in the database also, okay, to identify the log record. So log records, as we know, the system log record basically has the log record, along with it stores the LSN number, and the database also stores the LSN number to identify actually which field in the system log that are associated to the particular change in the particular page. Okay, in that particular page. So it basically connects uh, the pages which are being modified with the system log. Another information that is required is the transaction table and the dirty page table. Okay, so transaction table basically identifies which transactions were active, were in progress, and which transaction has committed. Okay, so that is being identified using the transaction table. Dirty page table actually identifies those pages which are being modified by a transaction. Okay, so these informations are uh, stored in the transaction table and the dirty page table. And in the dirty page table also we have the LSN value stored for the log record. As I told you, it connects between the page and the log table. So LSN number basically identifies which log record holds the changes in a particular page. Okay. So similarly, in this particular algorithm also checkpoints are being maintained. Okay. Checkpoints actually consist of the following informations like writing a begin checkpoint record to the log and writing an end checkpoint record to the log. Okay. So once this begin checkpoint and the end checkpoints are written to the log, there is also a special writing of the LSN is done to a special file. Okay. So begin checkpoint, the LSN of the begin checkpoint, which is recorded in the log file, is stored in a special file. This special file is basically accessed during the recovery, to identify the last checkpoint, actually checkpoint information, and that last checkpoint information is followed by the end checkpoint, which actually holds uh, the content of both transaction table and the dirty page table at that moment of time. Okay, so this is how these informations are important to extract or to consult the log file, so that the entire set of records can be recovered, or entire data items can be recovered by using the redo and undo operations. So that is how the way Aris algorithm works. We'll be analyzing through an example here, the snapshots. Now, whenever the system crash occurs, the Aris recovery manager basically takes over, and it identifies the LSN number of the last checkpoint, the immediate checkpoint where it is being stored. That particular LSN number is recovered, and from there it starts performing redo and undo operation. Now, how does this work? That let us identify through one example. Okay, say this is the scenario of a particular uh, system log at the time of the crash of a system. Okay, then when the system was running, this T1, T2, T3 are the three transactions that were executing, that were in the active state. Okay, so you can see here T1 basically updates a page ID C. So it sets some value, some update operation to the page C. Okay, the LSN is 1. Then comes the T2, which updates the page B, and LSN is 2. Then T1 commits. Okay, at this point a checkpoint is written, and the LSN 4 is stored in a special file. Then end checkpoint is basically written in the step 5, and then there are some other uh, transaction some other operations which are being performed, and when it was executing, after executing the LSN 8, this value, after updating this part of the log, the system crashed. Now at this point of time, the recovery manager has taken over. Okay, so it will just identify from here which was the begin checkpoint. Where was the begin checkpoint? It is at the LSN 4. So when this begin checkpoint, it identifies the begin checkpoint here at the LSN 4, it goes to the end checkpoint, and from end checkpoint, as I told you, end checkpoint actually stores both the transaction table and the dirty table. So this transaction table and dirty table are recovered at the end checkpoint. This is not shown here because this is the system log, but those are the save point where the two tables are, this transaction table and the dirty table are stored. Okay, at the end checkpoint, and from there it does the redo and undo operation to get the original values of the data, okay, to recover the data items. Now at LSN 5, the transaction table looks something like this. T1, the LSN transaction T1 has committed at the committed, and transaction T2 has basically was in progress. Okay, so this last LSN actually indicates the prior to this whatever LSN was there, that is indicated by the last LSN. Then comes the dirty page table. Dirty page table where the C is equal to page 1 and the B is equal to page 2. You can see this one, the C, this C is the page 1, LSN 1, and the B, dirty page B, is the update with the LSN 2. Okay. In the transaction table, you can see the transaction T1 was committed. The last value of the transaction at the till the time of the checkpoint was the committed one. So transaction T1 is mentioned as committed, whereas transaction 2 is not yet committed. So this is mentioned as in progress. Okay, that's what we find in the transaction table. This is what we find. That is the transaction T2 is in progress. Transaction transaction T1 is in committed. Okay, so transaction T2 is in progress and the transaction T1 is in committed state. And these were, as these are the LSN 1 was the dirty page table C, dirty page C. LSN 2 is the dirty page B. Okay. So after the LSN 5, where the end checkpoint was there, from the LSN 6, now the analysis phase will basically reconstruct the transaction table and the dirty page table. It will basically modify the original transaction table and the dirty page table and update this till the crash has occurred. Okay. So what it will do, will basically you can see at the LSN 6 the transaction T3 has modified the page A. Now this page A was not here, right? It is a new page which has become a dirty page because of the update operation by the T3. Now you see in the dirty page table here below, the A is inserted to the dirty page table and the 6 is also LSN 6 is inserted to the dirty page table. Similarly, for the transaction table, the T2 has committed and T3 has made the change. But one thing you remember, that transaction T2 has update here of the C, but in the transaction table we will only have the lowest LSN value where the update was done. That is what is maintained in the transaction table, because the redo operations will be starting from there, from the lowest value where the update was done, because it was a committed part. Okay, so we will not be modifying those values C, because this was still in progress, the T2. Okay, and only this particular part, that is the T2 commit, will be changed from T2 update. T2 was in progress earlier, it will become committed, and the T3 will be the new addition there in the transaction table. You can see here the transaction T3 has committed, right? Transaction T1 has committed. T2 has committed, sorry. Transaction T1 has committed earlier. Transaction T2 has committed in the LSN 8, right? T3 was still in progress. Okay, T3 was in the LSN 6 it has modified the value and it is in progress. Okay, that is what the transaction table will contain. Okay, now for the redo operations, what has to be done is that the smallest LSN value in the dirty page table will be considered. So what is the smallest LSN value of the dirty page table? It is 1, right? That is the what was the earliest modification done on the page, because the dirty page table indicates what the changes in the page, right? So it is basically the earliest modification was done by the transaction, I think transaction T1, okay, and the LSN 1, okay. So it will start from it will start redo operation from there onwards, the smallest LSN. Now it will do the redo updates for all the committed transactions, and these are basically 1, 2, 6, and 7. So you can see the LSN table in the system log. See the LSN number 1, LSN 1 has the T1 is the update. You see the type update. Okay, we know that T1 has committed here, so we can consider that. Okay, so it's basically the T1 is this 1, 2, 6, and 7 are the update operations. So 1 transaction ID does the update of the page C, dirty page C. Similarly, 2 transaction T2 updates. Okay, then T1 commits, then T3 updates in the uh, LSN 6, and then comes the 7. Okay, in the LS, then in the T2 in the LSN 7. So this page C is done by 2 transactions, T1 and T2. Both will be considered to the redo operation starting from the LSN 1. So it will basically redo the value set to the new value. Whatever new value was there with this one, old value will be replaced with a new value, and that redo will be done in the for the transaction T1. That is the setting the new value according to the dirty page table information. So similarly, the setting of the new value will be done for the page B for the transaction T2. Okay, all these remodification of the database item will be done, and then for transaction T3 will also be done. Though transaction actually T3 has not committed, still the redo operation will be done for transaction T3 in the LSN 6. Similarly, for 7, this update value page C will be again updated to a new value that was set by the transaction T2. Okay. Once the redo is completed, the undo operation will be carried out. Okay, so that is nothing but a backward operation. Okay, as only for the transaction which is not yet uh, committed. So at the time of crash, whichever transaction was not committed, that value has to be undone. For redo operation, committed as well as the transaction which are in progress, for all those the has been done. Redoing has been done. Consulting the system, the log, system log. Okay, but undoing operation will be basically undo phase will start from the entry of the start at the log entry 6. So last update of the T3, and then proceed backward. Okay, because we know that by consulting the transaction table, we know that only transaction which has not yet committed is the T3, and where T3 was in the LSN 6. Okay, so it will start from LSN 6 and it will go back in the reverse order. Okay, undoing the value of the particular uh, transaction, the page which has been modified by that particular transaction. So, and that particular value is undone by consulting the previous value, the old value. Okay, so though that is not shown in that particular system log, though it is not shown in the system log, you can see in the LSN 6 basically the transaction T3 is there. Okay, uh, but transaction T3 is in the progress state. From the transaction table we know that transaction T3 has not yet committed. It is in the still in the state of progress. So it will basically undo till some earlier value here on this side, which were there, to which the value can be set to the earlier value. Okay, so to that particular value it will be undone. So that is how it is done. First, the redo operation is done. Redo phase is carried out by redoing starting from the lowest LSN. Okay, by checking the dirty page table, whatever the lowest dirty page or the updated page LSN is found out, and that particular from there it starts starting modifying it again and again by consulting the log file till the last log record that is found. Okay, uh, like for the dirty pages. So dirty page last log was found as 1, 2, 6, and 7 for the updates. Okay, and then it carries out the undo operation for the failed transaction which is not yet committed. So for that, the undoing of the record is done. That is the resetting of the value to a previous value is done. Okay, that is done in the reverse order by following the reverse order of the updates. Now, after discussing the errors recovery algorithm, let us discuss the recovery in multi-database systems. Okay, so unlike the single DBMS, there may be some complex DBMS architecture where a single transaction called the multi-database transaction basically may require access to more than one databases. Okay, it may require access to multiple databases. Okay, so if suppose till now whatever we have discussed, a transaction basically deals with one particular type of database. Now here there can be different type of database to which transaction may require access to. The transaction may require access to some object-oriented database. It may require access to a hierarchical database. It may require access to a network database. Okay, so different type of um, databases to which the transaction may require an access to. Uh, that is like like unlike the normal relational DBMS, apart from the normal relational DBMS, it may require access to this kind of different specialized databases. Okay, in such cases, basically each DBMS involves some multi-database transaction policies. Okay, uh, and it may also have its own recovery techniques and transaction managers. And that may actually each of these recovery techniques and transaction manager may be separated from one another. So in such situation, how to handle the situation? So in such complex architecture of different um, database systems, different category database system, the to maintain the atomicity of the transactions, okay, the operations, uh, it basically two level of recovery manager is needed. Okay. It's necessary to have two level recovery manager. Okay. So uh, apart from its local, the normal log table and all for the recovery manager of the individual databases involved there, the for the transaction also deals with a global recovery manager, or it is also this global recovery manager is also called as the coordinator. Okay, the purpose of using global recovery manager is to basically coordinate among these different categories of the databases to which the transaction is dealing with. To recover, every individual databases here involved in this structure has its own log tables and a recovery manager. Apart from them, a coordinator is there, a global recovery manager. Now, this coordinator basically follows a protocol which is called as two-phase commit protocol. So now let us discuss about what is two-phase commit protocol for recovery in such kind of database structure where a transaction has to deal with different categories of database at the same time. In the phase one, when all the participating database signals, database basically signals to the coordinator. Uh, the coordinator, as we discussed in the above, that is the global recovery manager, that the transactions have the particular transaction has completed its execution in those individual databases, and it is ready to commit. Now when the coordinator basically receives such signal from each of the participating databases, it sends a message that is to prepare for commit to each participant, okay, and to get ready for committing the transaction. So basically the coordinator its job is to basically coordinate among those databases. So when it receives those information from individual databases, recovery manager of individual databases, that a particular update on the transactions has been done by the transaction and is ready to commit, then this coordinator basically prepares send a message prepare to commit to each of the participating databases. Okay. Each participating database receiving that message, what it will do, all the databases which are participating databases in that particular architecture, they will when it receives this message from the coordinator prepare for commit, it will basically force write all the updates that has been done to each of the database to their individual logs. Okay, and whatever additional information as we have discussed um, in the Irish recovery algorithm, those informations, commit checkpoint, etc., etc., those informations are basically written also to the log if it is required. Suppose some particular database actually is adopting those kind of recovery managers, then those information can also be written to the log file. Okay, and then send a ready to commit OK signal to the coordinator. Now in the phase 2, when all the participating databases reply OK, and then coordinator has also given a signal of OK, then that indicates that transaction is successful. Okay, and therefore the coordinator sends a signal, commit signal for the transaction to the participating database. So in that case, then what coordinator does, coordinator basically send a commit signal for the transaction to the participating database. Okay, after receiving this commit signal by participating database, they basically uh, saves this information or issues the commit signal by the individual participating databases. So now the recovery from these individual databases is become possible. Okay, it becomes possible. So what is the total effect that we find here from this um, particular system is that because of that global recovery manager concept, the net effect is that the entire set of transactions, no, all the participating databases commits or do not commit. Okay, because global recovery manager gives a commit signal to commit only when it receives the signal from the receives the OK signal from all the participating uh, databases. Then only it allows the participating databases to save. So resulting effect is that all the transaction commits and writes the log file, so making the recovery process possible. Okay, so this so the recovery becomes possible for such multi database systems. Almost all the important database systems like banking, insurance, stock market, etc., they basically adopt a method to recover from the catastrophic failure. Because catastrophic failure may be because of some very big region, maybe suppose maybe earthquake or some other accidental failure may occur because of the fire, etc., etc. So in that case, the the entire set of the database or entire database needs to be restored. So in such cases, there is for the important big database systems, the record needs to be periodically stored in some archival storage medium. So this archival storage medium is like some large and cheap data storage medium like magnetic taps where they are periodically after a certain regular period, I can say, those informations or those data are being stored in such medium. Okay, so in case of any untoward incident or say something like catastrophic failure, those tabs information stored in the tab, that is the most recent information that is stored in those medium, are stored back to the disk. Okay, and then some other recovery mechanism can be adopted over and above that particular, but it is the latest backup copy that has been stored in the tab or some additional medium, the safe location where it is stored is taken to the disk, and then uh, the logs are being applied, redoing operation or undoing etc. are done to uh, bring it to a most recent update position where it is being saved. Okay, so for critical applications like as I told you, banking, insurance, stock market, etc., this policy is followed to recover from such catastrophic failures.